Good morning, everybody, and welcome to the end of week 9. I know the weather's bad outside, but yeah, today we're going to review what we did in chapter 4, section 1. Remember, chapter 4 deals with polynomial functions. Polynomial function simply means it has many terms. All this tells us is whenever we deal with polynomials, always set them in decreasing order of exponents. Remember, this is called the degree. The largest exponent is called a degree. Always set it up there. And once you do that, the one with the largest exponent is called the leading term. In the leading term, the number in front of x is called the leading coefficient. And the n is called the degree. And all the way at the other end, the constant term, the one that doesn't have an x, is always the y-intercept. If there is no constant term, then the y-intercept is 0, so it's at the origin. We discussed last time also something called the leading term test. The leading term test gives us the shape and direction of the curve, of the graph. Okay, here we look at A, and here we look at N going down. Remember, N is the degree. The degree can either be an odd number or an even number. A is the leading coefficient. If the coefficient is positive or if it's negative. In other words, if the sign in the first term is either positive or negative. If it's positive and the n is odd, only thing we know for sure is that the ends of the graph point like that, opposite directions. If it's positive, it goes up at the right-hand side. Since it's opposite, it goes left and down and left. If it's negative, the leading coefficient's negative, then it goes down on the right-hand side. And whatever happens in the middle, we find out later. If the degree is even and A is positive, then we know that both ends of the graph point up. If the degree is even and the coefficient is odd, all we know is both ends of the graph point down. What happens in the middle, we don't know. So let's see here. Looking at the leading term test, let's go ahead and match these pictures with these functions. So A, which one would A be? A, B, C, or D? So we look at the leading term test. A is positive, so we know it's going to point up, and the degree is 4. It's even. So A is positive, N is even. A is positive, N is even. So we know the graph points up both directions. And the only graph that points up both directions is N. So the graph of A is N. And we also see the y-intercept is 3. That's where it's going to graph across the y-axis. Let's look at B. The degree is 3. So if the degree is 3, it's odd. That means both ends point different directions. And A is -5. So we know they point opposite directions, and the right-hand side goes down. So it's B. It goes down because it's negative, and since it's an odd exponent, they point different directions. Letter C. The degree is odd, so it points different directions, but A is +1. So it points different directions, and it goes up on the right-hand side. So it's A. And D, it's negative, so it points down. It's even. The degree is even. It's a 6. So they both point the same direction. They both point down. That was pretty easy, I hope. Yeah, so the only thing we should do is we should look at the largest exponent and the coefficient. If the largest exponent, again, if the exponent is even, both ends point the same direction. If it's odd, they point different directions. So look at the A. But then we look at the N. If N is even or odd, if N is even, that means both ends point the same direction. If A is positive, they point up. If A is negative, they point down. And if the degree is odd, then they point different directions. And the right-hand side tells you what direction it points. All right, so there's that one. Let's look at another one. Consider the polynomial x cubed plus x squared minus 17x plus 15. Determine whether each of the numbers 2 and -5 are zeros. How do we do that? Just plug them in there. Plug in 2 in there and then -5. And if equals 0, then these are zeros, which also means that x-intercepts. Which also we're going to learn today is we now know one of the factors of the equation. So that's what we're going to do today. Because remember, what we're trying to do is take larger equations like this and break them down to its smallest pieces. Because right now, in this question, I gave you 2 and -5 as zeros, to see if they're zeros. But what if I just gave you this equation by itself? That's what today's lecture is about. Okay, here we have an example that the function's factored already. So 4.1, example 3. We have f of x equals 5, x minus 2, x minus 2, x minus 2, x plus 1. If we're going to graph this, we know that these three are the same. So we could combine all those to make it x that cubed. And then we have x plus 1. So what this tells us, even though we have 1, 2, 3, 4 we have 4x's in an equation. Our degree is 4. The degree is the number of x's you have. That's the exponents. And if we add these, 3 plus 1 is 4. 1 plus 1 plus 1 plus 1 equals 4. So that's how we know our degree is 4. Since all the leading terms of x and the coefficient are all positive, we know a is greater than 0. So thanks to the leading term test, we know our graph will look something like this. So if we graph this, first is find the x-intercepts. Set these two equal to 0. And so we get x equals 2. That's one of our x-intercepts. And x equals negative 1. That's another one of our x-intercepts. So once you get to the factored form, set each one of the factors equal to 0 and put a dot there. That's our x-intercept. How do we find our y-intercept? This goes from chapter 1, section 2. Set x equal to 0. Solve for y. So in this equation, I set x equal to 0. And I solve. Remember, this whole thing equals y. 0 minus 2 is negative 2. 0 plus 1 is 1. Negative 2 times negative 2 times negative 2, or negative 2 cubed, is negative 8 times 1, which is negative 40. So we know that at negative 40, our graph crosses there. So we know the x-intercepts, we know the y-intercepts, we know the shape of the curve. We know that at the end behavior of the graph, on the farthest left point, the graph will go up. The farthest right point, the graph will go up. And we know it has to cross this point here, so the graph's going to be always down below the x-axis. But we also know, since the exponents of these factors are both odd, it's called a multiplicity. Whenever you have your factors, whenever you find the smallest factors of your polynomial, whatever the n is, if n is odd, the graph crosses at that point. if n is even. The graph bounces off that point and stays on that side of the x-axis. So since both of our multiplicities are odd, we know the graph crosses at those points. And we can have different things here. We can have the graph look different. All we know is that these two go up, it crosses the y-axis, and the rest of the graph is below the x-axis. That's all we know so far. To find the rest of the graph, we have to plot some points. Okay. So that's once we, so again, the hardest part is going to be getting to this point. So find the zeros. Let's sketch this graph. G of x is equal to negative x minus 1, x minus 1, x plus 2, x plus 2. So since this happens twice, the multiplicity is 2. And since x plus 2 happens twice, this is what we know. Since x minus 1 happens twice, we put a 2 there. And the leading is negative. Let's graph it, or the best we can, actually. To graph, we need the x-intercepts, the y-intercept, the degree, the shape, the a value. It tells us the direction. So what do we know about this equation? What's the degree? 4. Let's add the exponents. What's the a value? What's the leading coefficient? Is it positive or negative? Yeah, because inside here, they're both x's are positive, and outside it's a negative 1. So a is negative. It's less than 0. So n equals 4. The degree equals 4. All right, I'll put d then. Degree equals 4, and a is negative. So what does that tell us about the graph? Look at your leading term test graph. Both, since its degree is even, both ends either point up or point down. They point the same direction. Since it's negative, it points down. So all we know is from the end points, both directions point down. Our x-intercepts are at x minus 1 equals 0, x plus 2 equals 0. So they're at 1 and negative 2. Those are our x-intercepts. And I know since those are the end points, they both point down. What's our y-intercept? Is what? Have to make x 0. So we have negative 0 minus 1 squared, 0 plus 2 squared. So work that out. What do you get? So it's negative 0 minus 1 is negative 1 squared. 0 plus 2 is 2 squared. Negative 1 squared is 1. 2 squared is 4. 1 times 4 is 4. So the y-intercept is at negative 4. Now, since our multiplicities are both even, what happens at these points in the graph? Does the graph cross those or does it bounce? It bounces. So all we know is that it's something like this. The graph will have that shape pretty much. Now begins our trudge through finding those numbers ourselves, our factors ourselves. Whenever you have 4 terms, the first thing you want to do, if you have 4 terms, try grouping. Grouping is where you take the first 2 terms and put them inside parentheses. Since the middle term is a negative, you have to include that negative sign in the parenthesis in the second side. If it was a plus, the middle sign is a plus, then you don't have to put it in there. So place parentheses around 2 numbers. Second step. Factor each parenthesis. In other words, what do they have in common in the first parenthesis? Just one? Yeah, they both have at least 2 x's. You're right. They have the x, but there's 2 x's in common. So if I took away 2 x's from here, I only have 1 left. If I took away those 2, it's just the 2 that's left. And in the second one, since the leading term is negative, we have to factor out the negative. And what that means is everything inside there changes signs. And they both have a 9 in common. So we take out a negative 9. So again, when you factor something out, to see what goes inside the parentheses, just divide them. The negatives cancel, the 9s, so all we have is x. Positive and negative is negative. 18 divided by 9 is 2. Step 3. Factor out a common term. Because we only have 2 terms here. And they both have an x minus 2 in common. So I take out the x minus 2. And put everything else inside parentheses. In other words, place the coefficients inside their own parenthesis. So we have x squared, and we have negative 9. They go in their own parenthesis. Factor if possible. Can the first one be factored any further? No, it's a linear equation now. How do we know it's a linear equation? Well, the x doesn't have a power. Remember when we did in chapter 1, y equals mx plus b? That's a linear equation. X has nothing around or exponents or special signs. Actually, you could, at this point, you could set them both equal to 0 and solve. It may be easier instead of memorizing all the rules. Because if we just went from here and set them both equal to 0, our answers would be x equals 2. Add 9 to both sides. So we have x squared equals 9. Square root both sides. So x equals plus or minus square root of 9 is 3. So these are our 3 intercepts. How do we know we're supposed to have 3 answers? The degree tells us how many answers we're supposed to have. So at this point here, we could solve for zeros. Or we could have factored. This equation is the same thing as x squared minus 3 squared. It's a difference of 2 squares. Whenever you have 2 terms that are squared with a minus between it, it becomes that. So if I had x squared minus 7 squared, then it would be x plus 7, x minus 7. So that's the difference of 2 squares. Is this number a perfect square? Yes, it's made up of 3 times 3. So it's x plus 3, x minus 3. Now set all of those equal to 0. And we get x equals 2, x equals negative 3, and x equals positive 3, which is what these two tell us. Again, there's a lot of stuff. I'm not like there are a lot of procedures, a lot of things that you have to memorize from chapter 3 and chapter 4 that you have to memorize those in order to solve these equations. All right, let's look at the next example. Let's find the zeros of this one. f of x equals x to the fourth plus 4x squared minus 45. Do we know any method to solve this one? Well, it's a fourth power. But even though we haven't talked about anything with fourth power, we did learn how to solve trinomials. A trinomial is, remember that equation? What kind of equation is this? It has a power 2. So the graph is this or this. What kind of graph is that? Quadratic equation, right. These two are identical. Because you remember in the quadratic formula where we had x equals negative b plus minus b squared over 2a? Whenever you solve equations, we're solving for the middle term. And we know this is quadratic because if we take the middle term and square it, do we get the first term? Yes. We take the middle term and square it. So if we had x squared and we squared it, we would get x to the fourth. So this equation is what's called quadratic in form, because it's a trinomial and the square of the middle one is equal to the first variable. So if we had x to the eighth plus 2x to the fourth, is this one quadratic in form? Yeah, because if we multiply this one by 2, we get that one. So that's quadratic in form. So in other words, with that, if it's quadratic in form, we can either factor, complete the square, or use the quadratic formula. We can use any of those methods. So let's see here. Let's try to factor first. Now, to make things easier, remember when we factored this type of equation? What came here first was x and x, right? It's whatever the middle term is, goes there. So since this is x squared, it's x squared and x squared. The second sign is minus, which means both signs are opposite. And the bigger number gets the plus sign. So what times what is 45? When you subtract them, you get 4. It ends in a 5. So how many times does 5 go into 45? 9. So 9 times 5 is 45. 9 minus 5 is 4. So the 9 goes here, and the 5 goes there. Because we're looking for the solutions of this. We're asked to solve this. So we set it equal to 0, which means we take both of these and set them equal to 0. How many answers are we supposed to have? We're supposed to have 4 answers, and this is where we're going to find them. So take this first one, move the 9 over, so we get -9. Move the 5 over, so we get 5 on this side. Square root both sides. How did I get the positive or -9 on this side? I subtracted 9 from both sides. I added 5 to both sides. This is always the opposite. And I square, because the square root and the square cancel, so we have x. Whenever you take the square root of something squared, you have to put a plus or minus in front of the answer. So what's the square root of -9? We did this in chapter 2. What's the square root of -1 times the square root of 9? That's what this is. What's the square root of -1? What do you see with? An I. The square root of -1 is an imaginary number. Square root of 9 is 3. So it's 3i. So it's plus or minus 3i. Those cancel. Plus or minus square root of 5. These are our 4 answers. We have 2 x-intercepts and 2 numbers out in somewhere. So that's factoring. For this equation, could we have used the quadratic formula? If you're going to use the quadratic formula, remember, it's this equation here. This is always the middle number. So if you're going to use the quadratic formula, x squared equals -b plus or minus b squared minus 4ac over 2a. A is 1, B is 4, and C is -45. You treat it the same way. So -b, so we have -4, b squared, so it's 4 squared minus 4 times 1 times -45 over 2 times 1. Two times 1 is 2 on the bottom. -4 plus or minus square root. 4 squared is 16. Negative times positive is negative. Negative times negative is positive. 4 times 45. 16 plus 2 is 18. Again, you don't need calculators. You could do this in your head. So we have -4 plus or minus 16 plus 180 is 196. What 2 numbers multiplied together give you 196? let's try, what two numbers multiply end up with 6? 3 times 3, that equals 6. So let's try 13 times 13. Nope, that's 9. Not going to work. How about 14 and 14? 4 times 4 is a 6. 4 plus 1 is 5. 4, 196. So this number is equal to 14. The square root of 196 is 14. Because we took 14 times 14 and got 196. Remember, this equals x squared still. So because of that, we have x squared equals -4 plus 14 over 2, and x squared equals -4 minus 14 over 2. So I work these out. 14 minus 4 is 10. 10 divided by 2 is 5. Square root both sides. So x is equal to plus or minus square root of 5. Those are our two x-intercepts so far. X squared equals -4 minus 14 is -18, since they're both negative. Add the numbers. -18 divided by 2 is 9. Square root both sides. So x is equal to plus or minus 3i. Square root of 9 is 3. There's a negative, so it's an I. Same answers. Okay, that does it for section 1. Section 2. Graphing polynomials. Here are the procedures. To graph polynomials, do the leading term test so you know what the shape looks like. Find the zeros, find the x-intercepts, find the y-intercepts. Don't worry about writing that stuff down. We'll do this together. So section 4.2 is graphing polynomial functions. So let's look at this first example. We'll learn this by doing an example. -2x to the 4th plus 3x cubed. This box I put here is pretty much everything you need to draw your graph. Okay, we have the interval. We have the test value of x. the function value. Actually, I just put f of x. The sign of x and location of the point. Here's everything we need. So our steps. Factor the polynomial. So in our case, we have f of x equals negative 2x to the fourth plus 3x cubed. Notice we only have two terms. Whenever you have two terms, you're either going to use the square root method or the root method, or you're going to use the factoring method. In this case, what do they both have in common? They have three x's. So we can take out three x's. As far as we can go with that. So, second step, find the zeros. How do we find the zeros? Anything that has an x, set it equal to 0. And solve for x. For the left one, x cubed. How do we get rid of the cube? We take the cube root of both sides. And they cancel. Cube root of 0 is 0. So there's one x-intercept. And the other one, well, let's add 2x to both sides. 3 equals 2x. So x is equal to positive 3 over 2. This is my second x-intercept. All right. What we're looking for here is this. We know we have an x-intercept there. And we know we have an x-intercept because 3 over 2 is 1 and 1/2. So we have x-intercepts, both of them. Is the graph going to cross or bounce at those points? What's that? Yeah, look at this point here. Look at the exponents. They're both odd. So it's going to cross. It's a fourth degree, to the degree of 4, which means both ends point the same direction. It's a negative 2, so we know that both ends will point down. So from here and here, the graph will point down. And since we know it crosses at those points, what's going to happen up here is something like this, because it's a fourth order equation. Now, the way you use this chart, what I mean by intervals is if you look at your graph, you start at negative infinity and go to the first x-intercept. So we go from negative infinity to 0. And then from 0 to the next x-intercept, then we go from 0 to 3/2. And then the third interval is from 3/2 to positive infinity. What I showed you is much easier than this. If you remember all those things I just showed you down here, you know the x-intercepts. You know by looking at the multiplicities. If it's even, it's going to bounce. If it's odd, it's going to cross. You know the shape, the direction. That's what this is going to prove to us. Now, pick a number between negative infinity and 0, an easy number. -1. Let's pick a number between 0 and 3/2. Let's pick 1. And a number bigger than 1 1/2, let's pick 2. Because all this table is going to do is tell you in these intervals, in this interval, in this interval, and this interval, is the graph above or below the x-axis? So what we do now is take these values and put them in the original equation, in this one. So we take the test value of x and put it inside the function. All we want is the sign of what's going to happen. When we put in -1 inside here, is the answer going to be positive or negative? The sign of f of x. Let's see. At f of -1, we have -2, -1 to the 4th, -1 to the 3rd. -1 to the 4th. Anything to an even power becomes positive. Any number to an even power becomes positive. -1 times -1 is positive. -1 times -1 times -1 is negative. So if the exponent is even, the answer will always be positive. If the answer is, if the exponent is odd, the answer will always be negative, if it's negative. So we have -2 minus 3 equals -5. So at -1, the answer is -5. The sign is negative, which means it's below the x-axis. So all your numbers on this interval from -infinity to 0 will be below the x-axis. Well, that's what we decided already. Then we do the same thing here. F of 1. We have -2 times 1 to the 4th plus 3 times 1 to the cubed. 1 to the 4th is 1, so we have -2. 1 to the 3rd is 1, so we have 3. -2 plus 3 is +1. So this equals +1. It's positive. It's above the x-axis. Sure enough, that's what we decided. And if we do 3 we're going to get a negative number. It's below because that's what we decided already. So that's what this table is used for. So you can see the basic shape of your graph, where it's going to look like. It's going to be above, below the x-axis. How about this one? X cubed plus x squared minus 8x minus 4. Again, first thing we have to find the x-intercept. We have to factor it out. We have 4 terms, so what method are we going to use? We're going to use grouping. So take the first 2 terms, put it inside the parentheses. Since the middle term is negative, we have to include it in the parenthesis. Factor both of those out. What does the first one have in common? They both have an x squared. So I took away 2 x's here, so I just have 1 x left. What do I have in the second one? If I took away 2, what do I have left there? We have the coefficient, which is 1. A lot of people will just leave that blank, leave it empty, it's 0. But you have to be able to go from here. If we multiply this, we have to equal that. So that space has to be allocated. And the second one, it's a negative, so we take out the negative. 8 and 4 both have a 4 in common. So I divide both of these by negative 4. Negative and negative becomes positive. 8 divided by 4 is 2. X. Negative and negative becomes a positive. 4 divided by 4 is 1. The parenthesis goes out in front, and then whatever's left goes inside the second one. Now take both of these and set them equal to 0. And solve for x. 2x equals negative 1. X equals negative 1 over 2. That's one of my solutions. X squared equals 4. Square root both sides. X equals plus or minus the square root of 4 is 2. Those are my 3 answers. So my x-intercepts are these. What's my y-intercept? It's the constant. It's negative 4. So at negative 4, we have a dot on the y-axis. At negative 1/2, we have a dot. At +2, we have a dot. And at -2, we have a dot. What's the shape of the graph going to look like? Look at the original equation. What's the shape of the graph going to look like? Right. Because the degree is 3, both ends point opposite directions. Since 2 is positive, the right side goes up, the left side goes down. So from this side, it goes up. From this point, it goes down. So far, so good. Does the graph cross or bounce at these points? How do we know? Right, because at this point here, our exponents are 1. Our multiplicities. Because whenever we factor them out to this point, we look at the exponents of the parentheses. Do we have multiple of the same answers? No. These only happen once, so they bounce, they cross at each of these. So that's our graph going to look something like that. So I mean, it makes sense, or am I losing y'all? Okay. Just think, next week, you'll be able to solve this one right here. You'll be able to find all of these yourself. That's going to be cool. Example 3. X to the 4th, 7x cubed, 12x squared, 4x minus 16. Squared and x minus 4. How many answers are we supposed to have? 4 answers, right? All right, so what do we do first? Set each of these to 0. We need to find the x-intercepts. X plus 1 equals 0, x minus 2 equals 0, and x minus 4 equals 0. So those are x-intercepts. What's our y-intercept? Very good. It's at -16. What's the shape of the graph supposed to look like? They both go the same direction. Why do they go up? Well, because the leading term is positive. It's a +1. 1 is greater than 0. And this, they both point the same direction. They both point up. So the graph will look something like this. These are from the end points. So from this one, it'll go up. And from this one, it'll go up. What happens in the middle, we don't know. Is it going to cross or bounce at -1? It's going to cross because it's a odd exponent. So, and it also has to go through this point. What's it going to do at 2? Because it's even, it's going to bounce. And then at 4, going to cross. It looks something like this. What do y'all think? I mean, it's pretty much straightforward. Once you start to step back and look at it, it's just step by step by step. Okay. The intermediate value theorem. What the intermediate value theorem tells us is this. If we have a function on some interval, let's say AB, on some interval, and if we plug those values or two values in, and one side, one number is positive, one number is negative. If the answers at these 2 points, if they give you different signs, then one thing has to be true. If this is true, then there is at least one x-intercept between A and B. If f of A is up here and f of B is down here, and it's a continuous function, then there has to be at least one x-intercept at some value C. So there has to be an f of C where the graph is equal to 0. That's what the intermediate value theorem tells us. But only if we take 2 points and the answers have different signs. Let's look at this example. Let me write all 4 of these. F of x equals x cubed plus x squared minus 6x, where a equals -4 and b equals -2. So all we do is we have to do is find f of a, which is f of -4, -4 cubed, -4 squared, 6 times -4. All we're asking here is there an x-intercept between these 2 x points? Negative and cubed is going to be, the answer is going to be negative. 4 cubed is 64. Negative squared is positive. So 4 squared is 16. Negative and negative is positive. 6 times 4 is 24. So it's -64 plus 40 is -24. So at that point, we have a negative answer. What happens at f of b? At f of -2? negative 2 cubed plus negative 2 squared minus 6 times negative 2. Just plug those values in there. And all we care about is to see what the signs are. Negative cubed is negative. 2 cubed is 8. Negative squared is positive. 2 squared is 4. Negative and negative is a positive. 6 times 2 is 12. Negative 8 plus 16 is 16. Or is 8, I mean. Positive 8. So will we have an x-intercept? Yeah. Because if we graph these 2 points at negative 4, we got negative 24. We have a point there. At negative 2, we have positive 8. So the only way these 2 points can be connected is if it crosses the x-axis somewhere. That's the intermediate value theorem. Are we okay with that? Or no? Where got the 24?
Oh.
Right here. Yeah, but remember, when you have something like this, this is the x value, that's the y. So the point is negative 4, negative 24. This point is negative 2, 8. That's all you do is plug in the values and see if you get different signs. That's it for today then. We'll starting next week, we're going to start. I'm going to give you large equations like we just saw, and you're going to figure out what's going on. You're going to graph the whole thing with me not giving you any other information. Okay, everybody, have a great, safe weekend.